Good afternoon, everyone. It's nice to be here at Google Cloud Next. Um, so my name is Amar. I'm a director of AI at Hughes Network Systems, part of EchoStar. Our goal is simple: to create a more connected world. And we do this by creating a lot of cutting-edge solutions that you see here, from 5G to in-flight connectivity to cybersecurity. And that's how we connect people, enterprises, and governments across the world. But today I'm here to talk about how we use AI. So this is an overview that we apply AI across various modalities: speech, text, vision, documents, and structured data using various AI techniques and models, machine learning, deep learning, and generative AI across various functional areas like field services, customer services, quality assurance, and also providing the um, fault management system in the in-flight connectivity. Um, and if you see here, these are some of the metrics. We already have 12 applications running in productions, and more than 10 are in development. And we have uh, able to scale fast by creating some frameworks, and we processed billions of tokens already. And we processed around 2.5 million calls, generated a lot of images that we use to train traditional computer vision models. And then off late, we are trying to generate a lot of videos as well. And the way we are able to scale is by creating reusable frameworks. So we have created frameworks to analyze data of different modalities for call analytics, for searching our documentations, creating virtual assistants, and also to analyze our documents, and also for building agentic AI frameworks and observability, and also LLM ops, um, which is at the center of that, right? And we know that there are a lot of risk associated with generative AI. We know with LLM attacks, prompt injection, copyright issues. So to mitigate all of this risk, we came up with a very strong governance and strategy across different layers, starting with the data privacy and security, and also governance. And we have also incorporated the responsible AI into our applications. And you'll see that in the coming slides. And we also have worked closely with the legal team for legal indemnification and IP protection, right? And here is a snapshot of our observability dashboard. On the top, you can see the various guardrails that we have created, which analyzes the response of the LLMs and the inputs real time, helping us detect data loss prevention early. And also, you can see we are measuring the performance and quality of the responses from the LLM, and also collecting the human feedback at the same time, uh, and also keeping a track of the cost and the number of tokens that it has processed. And diving into some of the use cases that we have been building with respect to field services. So we are empowering our technicians with some of the tools wherein they're using video analysis to do the site surveys and also to audit the installations. We are using computer vision, using image audit, and also we have provided them with a virtual assistant with which they can ask any questions that they have, right? In the backend operations, we are helping the operations team with call analytics and summarization of the service order activities and selecting the right ordering template, and also analyzing a lot of contracts that we sign with our other partners, right? And AI has also played a significant role in our quality assurance with respect to understand our customer sentiment, wherein we are analyzing the calls, surveys, and also the cases that the customers created for better retention. We are also looking at the installer notes to help us optimize our truck rolls and collecting the feedback from the customers on the surveys that we send them out regularly, right? We're also auditing the sales agent to check if they are following the script that has been given to him so that they don't deviate from it, right? And in customer service, for the customers, we have provided a self-service chatbot uh, with which they can get answers to a lot of the questions related to billing, technical questions that they have. And in the back end, we are providing the agents with a lot of tools with respect to the knowledge-based search, automated call summary, so that they don't have to type the case notes after the call is done. And we have seen tremendous benefit on that use case. And also, while the call is going on, we can real-time detect the intent of the call that the customer made and hook it up using the knowledge bases and the tools that we have and real-time assist the agents. This is a textbook use case of agentic AI, and then we are working on that as well. And AI has a significant role in security operations, and we have rolled out an application for the security operations here, which does threat detection, remediation, and then we correlate it with intelligence integration, and with which the security team is able to generate a lot of reports. And we have used, again here, agentic AI. Now, we have seen tremendous benefits already with all these use cases that are running in production, and calculating ROI is one of the key areas that we spend. So the way we do it is by measuring a unit of work pre-Gen AI and post-Gen AI. As you can see, in the customer service, we are almost saving 30,000 hours annually just by summarizing the call, right? Similarly, in the service order activity summarizer for the fields operations team, we're increasing the efficiency by 20%, saved around 5,000 hours. And with the sales call audit, we had manual auditors listening to these calls, spending a lot of hours, and we automated that entire audit using AI, and we saved a lot of time and money there. So what we have seen is there's a role of AI in every single process within the company, and then we are seeing the benefits of that. And Google Cloud is where all these applications are being orchestrated, and AlloyDB is one of the key components of it. We have a lot of applications of AlloyDB, but today I would like to focus on these four, which is the call analytics, how we are able to train the computer vision models faster using vector search, and also how we are using AlloyDB as a long-term memory for agentic AI, and also how we are able to generate text to SQL and also text to Wiz. But before I jump into the next slide, I would like to play a demo of the call analytics platform.
Every support call contains invaluable hidden insights. Our advanced AI platform uncovers these and enables our field services team to precisely identify root causes of issues and implement targeted corrective actions. Pose your questions using everyday language, and our platform converts them into database queries using NL2 SQL. Meanwhile, vector search finds meaningful patterns and connections that would otherwise go unnoticed. Need visualization? Our platform creates comprehensive dashboards in moments, delivering instant, insightful analytics displays precisely tailored to your specific requirements.
As you saw in the demo, using the natural language, the final output was a visualization, a dashboard. And we have used AlloyDB NL2 SQL and vector search to be able to come with that. So we are using the call analytics for mainly four things: to get advanced call insights into this calls. What's happening? What are the issues that are being faced on the field? What are the resolutions? How can we find the root cause? And also to measure the quality of our agents, right? How well they are performing on the calls, correct? This is also helping us to enhance our knowledge base, and also using it, we are able to train our agents faster, right? So let's look at the flow. The way it works is we take the raw audio, transcribe it, apply LLM to it, get some key insights, which we store in LIDB. But a lot of this has a descriptive output. That is where we are using vector search to basically get better insights, right? And so once this data is in the LIDB database, any user can come here and query it. And that's how we are able to gather actionable insights. Now I'll jump into the second demo, which shows how we are using LIDB to train our computer vision models faster.
Our AI vision analysis is making perfect satellite internet installations a reality. In the field, our installation apps give technicians instant feedback on site quality. See that obstruction blocking a clear view to our satellite? Our AI segmentation models, running directly on the technician's phone, instantly identifies it, providing a clear site survey in real time. But it's not just about a clear line of sight. Our AI also audits the installation quality of the setup itself. This means fewer errors, fewer repeat visits, and more satisfied customers.
So as part of the field services operations, the installer on the field is required to take a lot of images, videos, and for that, we have to train a lot of conventional machine learning models that run on the edge device, right? So what we have done here is using generative AI, we have created a lot of synthetic images and also intelligently labeled them. And that is one of the pain points in training these computer vision models. A lot of effort goes into creating the training data set by annotating them. And this is one example. If you have to train a computer vision model to detect what a sky versus tree is, somebody has to sit and annotate that image and then label it, which goes as an input to the traditional computation model. But we thought with the power of vector search capability in LIDB, if I have this original image that you can see, using the open source SAM library, I can detect all the masks inside it. And then for each of the masks, I can generate embeddings and persist it in the LIDB. And then I know what is my region of interest, right? Here is the radio. Then I can generate embeddings for it. And then with that, I'm easily able to create a training data set, which will be used to basically train the edge models that run on the device. So with this, we are really able to train conventional AI models faster, and it's saving a lot of time and increasing our productivity. I'll jump now to the last use case that we have, where we have used agentic AI as long-term memory.
Our AI-powered operations assistant transforms incident response for SRE teams using agentic AI, eliminating tedious manual troubleshooting. Seamlessly integrated with GCP cloud APIs, databases, and codebases, it leverages real-time context and continuous learning from past incidents. It autonomously detects alerts, examines issues, and pinpoints root causes, delivering actionable insights through an intuitive conversational interface. With our operations assistant, free your engineers to focus on innovation.
So a lot of time is spent by the SRE team to diagnose, find out the root cause, do code fixes, and based on that, take some recommended actions. So this is a textbook use case for agentic AI, wherein we can provide the agent all the tools that an SRE team has. And memory plays a key role here, the short-term memory and the long-term memory. And that is where we have decided to use the inbuilt capabilities of LRDB, like natural language to SQL, vector search, and the inbuilt LLM If you look at how the long-term memory is classified, it's classified into three segments. The episodic memory, that in this case is about the past incidents. Semantic memory is about all the architectures and run book information, and procedural is about the workflows. So by using the inbuilt capabilities, we are really able to make this agentic AI application more intelligent. And lastly, I would like to conclude with some core principles that have really helped us build these scalable AI applications is to keep the architecture simple. Most of our applications are using serverless components, and also bring and use reusable frameworks, right? You must have seen in the demos. And then start small and build on top of it. And governance is a key part to it. And plug and play. What I mean here is if LOIDB already has these inbuilt capabilities, so we can use them out of the box. So, and thank you for your time.